In the 21st century, India has witnessed huge technological developments across all sectors. Yet, even today, all economic and societal applications of strategic importance like agriculture, disaster management, defense operations, energy, tourism are heavily dependent on accurate weather prediction. Weather predictions have improved remarkably, but what we take for granted now was simply not available in the not-so-distant past. The persistent inclement weather during Rabi season between 1982 and 1983 caused widespread damage to standing crops over northwest India, as the farmers did not get sufficient time to plan remedial action. This episode caused widespread concern, subsequently leading to the formation of National Centre for Medium-Range Weather Forecasting in the year 1988 as a dedicated centre for generating quantitative weather forecasts for next 10 days. The centre is located in the institutional area of Sector 62, Noida, and is dedicated to the development of advanced weather prediction modelling systems through continuous R&D and demonstration of novel applications. The first and the foremost challenge for NCMRWF was to build an infrastructure and empower its workforce with the requisite technical know-how to set up relevant modelling systems and to generate accurate weather forecasts with sufficient lead time for Indian farmers. Moving forward in this journey towards achieving excellence, the first supercomputer system in India was installed at NCMRWF in 1989. This ushered in the high-performance computing era, particularly in the field of Indian meteorology. Fast computers are essential for quick generations of predictions with enough lead time, as weather modelling involves enormous computations in four-dimensional space. Progressively, NCMRWF has been augmenting its high-performance computing facility in a phased manner from 234 megaflops in 1989 to 350 teraflops in 2015, with 16,000 processors to work with massively parallel weather codes. The reinforcement of computing facilities resulted in development of very high-resolution global models and assimilation of large volume satellite observations required for accurate weather prediction.
NCMRWF is a specialized center of MOES specialized in developing atmospheric model as well as a data assimilation system. They recently developed a state-of-the-art atmospheric prediction system for short-range weather forecast, and they are specialists in data assimilation packages. They have recently developed special algorithms for developing data assimilation systems into numerical models, especially assimilating satellite data, including Indian satellite data.
One of the key initial achievements of NCMRWF was the development of Agro meteorological advisory services, or AAS, for the different agroclimatic zones of the country. Agro-meteorological bulletins on quantitative weather information with 5 days lead time generated from model output were used for professional farm operations. This resulted in significant economic benefits in the agriculture sector. After its successful establishment and demonstration in 2007, NCMRWF transferred the Agro-meteorological advisory services to the National Weather Service (IMD). NCMRWF has been playing a key role in developing and implementing advanced dynamical weather prediction systems for India and the neighbouring region, and is a lead centre of the Ministry of Earth Sciences for Weather and Climate Modelling. In fact, today, NCMRWF is the only centre in the South Asian region assimilating global observations from various sources like surface AWS, ship, buoy, radar sonde, aircraft, satellite and radar. Data from recent Indian satellites, INSAT 3D and Meghatropics were also ingested. The observations are recasted over the model grid to generate a three-dimensional present state of atmosphere and subsequent predictions of different weather conditions.
NCMRWF has a seamless prediction system for all space and time scales. Currently, we operate a 17-kilometer global model and 4-kilometer and 1.5-kilometer regional models. We employ four-dimensional variational assimilation to assimilate satellite and radar data in a most appropriate manner. A 44-member ensemble prediction system is used for generating probability forecasts. Recently, we completed an 11-year global reanalysis at 25-kilometer resolution. The atmospheric forcings from our model are used by INCOIS and Indian Navy to drive the wave and ocean models in real time.
Validation of the model prediction is crucial to establish its credibility amongst stakeholders. This validation exercise also provides useful feedback for the model improvements.
Verification of model forecasts is a very important component of the research and development activities at NCMRWF. The verification of the model forecasts are carried out both against the analysis as well as the observations. A comprehensive set of the verification scores not only gives a summary of the model performance, but also indicates the suitability of the model forecast for a variety of applications. Some of the new applications which require weather forecast are in the renewable energy sector. Both the generation and the forecasting of wind power as well as solar power, they require forecast from NCMRWF.
The current model has good skills in predicting extreme weather events like tropical cyclones, heavy rains and heat waves.
As you know that with global warming, we are expecting a lot of increasing severe weather events in the country. To predict severe weather events, we need to develop an ensemble prediction system in which we can issue probabilistic forecast for severe weather. So, they have recently developed a state-of-the-art ensemble prediction system with a lot of data assimilation, good data assimilation packages, so that we can issue forecast for severe weather in probabilistic way.
Tropical cyclone Roanu developed over southwest Bay of Bengal on 14th May and crossed Bangladesh coast on 21st May 2016. The track of the system was predicted accurately through NCMRWF's global model. Around the same time, the temperature over Rajasthan and adjoining region was more than 50 degrees centigrade for 3 consecutive days. A red alert for the heat wave was issued by IMD, and this extreme condition was predicted 7 days in advance. Recent heavy rains over Madhya Pradesh associated with monsoon low between 9th and 10th July was also predicted accurately through this model.
We are working on the modeling of water cycle, in which we want to quantify the water cycle components at the river basin scale in India. For this purpose, we have chosen 2 river basins as a pilot. One is Satluj river in Himalayas, where snow melt and rainfall both contribute to runoff, and Narmada river in the central India, where only rainfall is important. We have computed all the components of the hydrological cycle for these 2 river basins, and snow melt process has been modeled for the Himalayan river basins, and we have computed the river discharge at the Bhakra dam, and for Narmada river basins we have computed all the hydrological components of the entire basin, considering the land use, land change cover. These studies are going to be very important in the context of climate change over India, and we are going to extend the study for all the river basins in India and study the future hydrological cycle.
NCMRWF is jointly developing this model further along with the UK Met Office, the Bureau of Meteorology Australia, the Korean Meteorological Administration and the National Institute of Water and Atmospheric Research, New Zealand. As a regional leader, NCMRWF has been extending technical cooperation to the Bay of Bengal rim countries. BIM-STEC Centre for Weather and Climate has been established at NCMRWF. NCMRWF is also supporting RIMES, Association of Countries from Asia and East Africa, in generation of weather-related early warning information. The creation of NCMRWF has generated tremendous impetus to the growth of dynamical weather modelling discipline in the academic and R&D institutions of India. NCMRWF has been contributing immensely to human resources development in the field of weather modelling and data assimilation. Over the years, young students, scholars and scientists from India and neighbouring countries have been trained at the centre. NCMRWF is a preferred choice of Indian defence organisations for their training needs in weather modelling.
For tropical region, the physical processes are the most important thing contributing to the rainfall and circulation. And among physical processes, the ocean-atmosphere interaction, the land surface atmosphere interaction, they were not being included earlier. Now with the availability of bigger computer, we are now including explicitly ocean and atmosphere coupling and the land surface models into the weather model. And we have good amount of data from the land surface and from the ocean. So now a full earth system model having the ocean, atmosphere and land interaction is being developed. So this will produce much better rainfall from the weather system. So for the coupled system, we need all these three components to be included into the model.
Favourable monsoons in India provide an impetus to agriculture, which in turn boosts the economy. An independent study has also shown significant economic returns while utilizing model-based weather predictions.
The recent advances in modeling and data assimilation aided by the ingest of more data have resulted in improvements in the medium range prediction skills. High resolution forecasted from 1.5 kilometer model will be used for high impact weather systems and block level real time predictions. A high resolution 12 kilometer global ensemble prediction system with 44 members is expected to be operational by 2019.